Pick up a rough diamond straight from the ground and most people would walk right past it. It looks like a dirty, dull, yellowish pebble. Nothing glitters. Nothing catches the light. There is no obvious reason to look twice. That same stone, after passing through one of the longest and most demanding transformation processes on Earth, ends up behind glass in a jeweler's window with a price tag that can exceed the cost of a house. What exactly happens between those two moments? How does something pulled from deep underground, coated in rock dust with no shine and no obvious beauty, become the object that sits at the center of proposals, anniversaries, and some of the most expensive transactions in human history? The real reason a rough rock becomes a diamond is a story of pressure, time, machines, and the meanings people decide to attach to things. Let's get into it right here on Small Things. Carbon with a different destiny. At its core, a diamond is carbon. The same element found in charcoal, in pencil lead, in every living thing on the planet. What makes it different is not what it is made of, it is what happened to it. Under extreme heat and pressure deep inside the Earth, carbon atoms are forced into an interlocking lattice, so tight and perfectly ordered that the result is the hardest natural substance known to science. The finished stone is cold, dense, with a transparency that splits light into color when cut at the right angle. It scratches every other material and resists almost all chemical reaction. And yet it began as the same unremarkable element as the tip of a pencil. The difference, entirely, is what it was put through. The meaning we gave the stone. It did not begin as a symbol of love or wealth. For most of human history, diamonds were valued primarily as cutting tools. Ancient civilizations in India, where the earliest diamond trade is recorded as far back as the 4th century BCE, recognized that diamonds could scratch any surface and could not be scratched in return. They were used to engrave harder stones, to sharpen tools, and occasionally worn as talismans believed to carry protective power. Their rarity made them desirable, but they were not yet the romantic symbol the modern world knows. For centuries, that was all a diamond was, an exceptionally hard material with limited but useful physical properties. That changed slowly as diamonds moved along trade routes from India into Persia, then into Europe, arriving at the courts of medieval kings and nobles. By the 15th century, the diamond had become a stone of prestige among European royalty. The first recorded use of a diamond engagement ring dates to 1477, when Archduke Maximilian of Austria gave one to Mary of Burgundy. The gesture was noted and admired, but it remained largely a gesture for royalty and the very wealthy. Ordinary people had no part in it, and for centuries the tradition spread only slowly beyond the aristocracy. What shifted everything was not a discovery or a geological event, it was an advertisement. In 1947, the De Beers Mining Company launched a campaign built around 4 words: "A diamond is forever." It was not a description of the stone's physical properties. It was an idea, carefully constructed to link diamonds with enduring love and to make the diamond engagement ring feel like a universal tradition rather than a recent and deliberate commercial invention. The campaign worked on a scale that is almost hard to measure. Within a generation, the diamond ring had become an expected part of proposals across the United States, then across much of the world. Jewelers reported dramatic increases in sales. The practice spread into countries and cultures where it had no historical roots at all. A geological accident, combined with one of the most effective advertising campaigns in history, became a global cultural ritual. The stone had not changed at all. The meaning people decided to pour into it had transformed entirely. And that meaning proved more durable than almost anyone anticipated. From deep earth to the surface. So how does a diamond actually get from deep inside the earth to a ring in a jeweler's window? It starts roughly 100 miles underground, where temperatures reach around 1,500 degrees Celsius and pressures exceed 50,000 atmospheres. Under those conditions, carbon atoms are forced so closely together that they form the rigid crystalline structure of diamond. The process takes billions of years. The diamonds in a jeweler's window today were formed between 1 and 3 billion years ago, long before complex life existed on the surface above them. They reach the surface through ancient volcanic events, carried upward through narrow channels of molten rock fast enough to prevent them converting back into graphite. This volcanic material, called kimberlite, solidifies around the diamonds and holds them in place. Kimberlite pipes are what miners search for. Some are narrow and deep, others fan out into vast open pits stretching more than 1 kilometer wide and nearly 500 meters deep. Explosives blast the rock loose. On average, around 250 tons of rock must be processed to yield a single carat of rough diamond. Once at the surface, the rock is crushed in stages, calibrated so the force breaks the surrounding kimberlite without shattering the diamonds inside. The material is washed, fed through X-ray scanners that detect the unique fluorescence diamonds emit, then separated from waste with a targeted burst of compressed air in under a second. What remains is a collection of rough stones, dull, uneven, completely ordinary-looking. Each stone is scanned in 3 dimensions, its internal structure mapped by software that calculates how to cut it for maximum value and brilliance. The cutting is done with a laser, precise to 1,000th of a millimeter. The facets are then ground and polished using wheels coated in diamond dust, because only diamond is hard enough to shape diamond. The whole process from rough stone to finished gem can take weeks. At the end, the stone that looked like a dirty pebble is emitting light in every direction. Hard does not mean indestructible. The most common assumption people make about diamonds is that because they are the hardest natural material on Earth, they are essentially indestructible. That assumption is only half right. Diamonds are extremely hard, which means they resist being scratched by almost anything. But hardness and toughness are different properties, and diamonds are not particularly tough. The crystal structure that makes a diamond so hard also gives it directional weak points called cleavage planes. Along these planes, a sharp impact at the wrong angle can split a diamond cleanly in two or shatter it into fragments. This is why the crushing stage in mining is one of the most carefully managed steps in the entire process. Too much force, or force applied at the wrong angle, and a diamond that could have become a $1,000 gem becomes industrial grit worth almost nothing. The machines calibrate their pressure to break the surrounding kimberlite while leaving the diamonds intact. The same risk continues through cutting. A skilled cutter studies a rough stone's cleavage planes before making a single cut. The laser is aligned along the stone's geometry, not against it. A single miscalculation on a large rough diamond can destroy a gem worth hundreds of thousands of dollars in a fraction of a second. The vulnerability of something so hard is one of the more counterintuitive facts in materials science. What protects a diamond is not its resistance to force, it is the precision and patience of the people working with it. What the stone carries with it. Today you will find diamonds in settings far beyond the jeweler's window, each one carrying a trace of the journey that produced it. Industrial diamonds, the majority of all diamonds mined, are embedded in drill bits, cutting wheels, and grinding tools used in manufacturing, construction, and precision engineering. Because nothing else cuts as efficiently at the hardest end of the material spectrum, diamonds are present inside factories, oil rigs, and operating theaters in ways that most people never see and rarely think about. In luxury jewelry, the certified diamond has become one of the most scrutinized commercial objects in existence. Each stone receives a laser-engraved identification number along its edge, invisible to the naked eye, and an official certificate from institutions like the Gemological Institute of America. The certificate records the stone's cut, color, clarity, and carat weight, turning a piece of compressed carbon into a documented, traceable object with a verifiable identity. There is also a harder layer to the story. In parts of West and Central Africa, diamonds are still extracted by hand in conditions that bear no resemblance to the controlled precision of a large mining operation. The gap between what a stone sells for and what the person who found it receives is, in some cases, almost complete. The beauty of the finished object does not erase the conditions of its beginning. The stone carries all of it: the geology, the machinery, the craft, and the human cost, whether or not the person wearing it knows. Pressure, time, and human meaning. So, how does a dirty rock become a diamond? Through billions of years of pressure underground, hundreds of tons of rock processed for a single carat, weeks of precise cutting and polishing, and a final layer of meaning that humans have been adding for centuries. No single step is trivial. Remove the extreme conditions underground and there is no crystal. Remove the precision of the cutting and there is no brilliance. Remove the meaning people attach to it, and there is no desire. A diamond does not shine only because of light. It shines because of billions of years of pressure, tons of rock, precise human craftsmanship, and the meaning people attach to it. The next time you see one catch the light, you are not just looking at carbon, you are looking at the full length of that journey. If this changed the way you think about the stone sitting quietly in a ring or a window display, let us know in the comments what you want us to explore next. We might make it our next episode. Thanks for watching. History often hides in the smallest details.